everyone, welcome back to a Pre-Calculus 12 video. We are continuing with Chapter 3, which is on polynomials, and today we're going to be focusing on graphing polynomial functions, and we're doing the first half of it. As usual, I've split it up into chunks, so we'll do the first half in this video, and then I will give you the last half in the next video, and that way it'll just make it a bit more manageable and it'll give you a chance to practice some of the skills instead of having a whole bunch of it piled on you at once. Okay, the nice thing about today's video is it goes very nicely with the one that we just did last day. Last day we looked at the algebra and we got a clear picture of the effect that multiplicity has on equations and how we find the multiplicity using the equation. And today we're going to look at the graphing version of that, which is nice because I want you to get into the habit of viewing the algebra and the graphing as helpful tools. It's not a bunch of separate things that you're doing. It's all connected and it's showing you the same thing. So if you can view it that way, I think that it'll make this more manageable for you. So this looks like I'm about to teach you a dance. If you look at it, there's three different effects that multiplicity can have on the shape of a graph. By multiplicity, I've underlined here that it's zeros. That's where you would find the multiplicity. It's from the zeros or the x-intercepts or the roots. They all mean the same thing. And the three effects are cross, bounce, or slide. See, they sound like dance moves. They probably are dance moves. So make me a TikTok video on this and send it to me and you'll get bonus marks. But getting back to this, you've actually seen all of these things. You just didn't know that this is what they were called and you've done them separately, but now we're going to start putting them together. But before we get to the point where we put them together, I am going to show you not a full equation, but just maybe a portion of an equation so you can start to see how this is going to end up looking. So if I give you an example like, so let's do x minus 4. I'm going to put it in brackets just so that it looks like the thing that you see above there. But ultimately, like this has a little 1 there, we just never write it down. And so if I had an equation, it's not an equation, I guess it's a section of an equation, but that says x minus 4. If I went to graph that out, I know that at positive 4, I must have a root according to this, because it's in factored form. And then it's just crossing at that point. And since I don't see anything else surrounding this, I'm going to assume there's a slope of 1 in front of this x. So it would go up 1, over 1. So I know that it's a line that's kind of going like this. So there might be other stuff going on in the graph over here to the left. But this is the only portion we're interested in right now. So maybe the thing I want to show you is that the cross is just referring to this point. So I would say there's a cross at x equals 4. Okay, so then if we move on to a bounce, maybe I'll give you another example here. A bounce happens when we have an exponent of 2, so a multiplicity of 2. An example of what that might look like is, let's say I give you x plus 3 squared. If I go to graph that out, I know that at minus 3, I'm going to put a little dot there. Something's happening at minus 3, and you've actually done these before. This looks like the parabolas you worked with last year. So I know that it would have a parabola shape like this, and when it gets to the bottom here, it's bouncing at 3. So look at this. I'm going to color coordinate all this for you. So here, it would have a bounce at x equals minus 3. Okay, so then moving on to the last one, x minus a to the power of 3, that's where we would get a slide. So this is a multiplicity of 3. Let's take a look at an example of something like x minus 2 cubed. You've even seen these before, but you probably didn't know what they were called. So at positive 2, I have what's called a slide. I'm going to, you know what, for a second here, I'm going to really zoom in on this. So I am going to completely exaggerate this for you. So If, let's say, I have a graph that's going from down here, when it hits 2, how can I exaggerate this and show you? It's kind of like sliding or hanging out there for a bit before it comes up. So I don't know if you can see that properly. I did my best to sort of exaggerate it. It's not just simply crossing through. It's sort of hanging out there for a bit before it comes up. So what is the slide is this portion here. I would say there's a slide at x equals 2. So that's the effect or the impact that the cubed on the factored x minus a has. Okay, so we have looked at these individually so that we could get to the point where we can start to put things together. But I wanted you to first know what the 3 impacts are of the different types of multiplicity. At any point, if you need to, of course, pause, do what you need to be able to keep up and follow along with this. Okay, so I've written the page number here because you actually have all of these written down on that page number, but you also should have all of these notes that I'm writing on. I've sent to you in your Microsoft Teams class notes folder. So up to you if you want to write these down or add information to them if you've printed them off. But let's just quickly go through this. Here are the steps for graphing polynomials, because basically so far we've been like picking up on little skills or little tools to put together so that we could get to this point where we can graph anything. Step number 1, find the roots by factoring and setting f of x equals 0. We did that before. 2, find the y-intercept, so that would be where x is equal to 0. Step 3 is determine the shape at each root. So using multiplicity, figure out, is it a cross, is it a bounce, or is it a slide? Step 4, determine the end behavior. So we would find that by looking at the degree and the coefficient. Step 5, determine the number of turning points or the changes in direction. So I went through this in the last few videos. Step 6, use the x value between roots. This is my symbol for between, to estimate the highs and lows of the graph, the max and the min. So I'll go through that with you. Step number 7, plot a reasonable number of points and draw a smooth continuous curve. Okay, this is the whole reason why we did all of this. We are going to take this example, graph y equals blah, 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 blah. The nice thing is most of it has been factored out for you. And then we're going to run through these steps and graph it out. So let's work our way through this together. I'm going to get rid of those points, but you should have them in front of you or near you so you can access them while we go through this. So the first step is, it says to factor and set this equal to 0. So it's actually looking pretty good, except for this one. We don't want it to look like that. We want the x at the start and the number as the second term. And we don't want a minus x, we want it to be a plus x. So we can take this and we can actually rewrite this to say negative x squared. So I've pulled out this negative all the way to the front, times x minus 2 squared. And then here, I can rearrange it and it becomes x minus 4, because what I did to pull out the negative is I divided both of them by a -1. So that's what ends up giving us this to work with. So what that means, like I would also want to set this equal to 0. And what this means is that my roots would be at, and notice how this is an x squared, so it has a multiplicity of 2. I don't really need to write the 2 zeros. I mean, that just tells me there's a root at 0. I'm doing this to make it super clear for you. So this is sort of ridiculous that I'm writing it twice, but this is a good way to sort of highlight or keep in mind the fact that you have a bounce at that spot and to not forget. Same thing here, multiplicity of 2, so it's actually going to be that, and then at 4. So actually 1, 2, 3, 4, 5, that makes sense if you count the number of x's here. X squared, so there would be 2 more there and 1 there. So yeah, it makes sense that we should have 5 roots in total, although there's multiplicity of 2 on a few of them. So we also want to find, well, here's step number 1. Let's do step number 2, which is finding the y-intercept. So y-intercept, and I'm just going to abbreviate it like this, that happens when my x value is equal to 0. Okay, so I just do that by plugging it into the equation here. So in my equation, I'd have negative 0 squared, 0 minus 2 squared, and then, 0 minus 4. So I just took this equation in nice factored form that we found here, and I've just plugged this in. And basically we're just doing that to figure out what we would get. And when we work our way through this, look what ends up happening. We actually, like, this is all being multiplied by 0. So the whole thing is just 0. So the y-intercept is going to be at the point 0, 0. Right? Because we had the x squared at the start. So if I plug in a 0 to there, it didn't even have to carry on. The whole thing's just going to be 0. So we have that. Step number 3. Looking at the multiplicity, we know we have a bounce at 0. And we have a bounce at 2, and we have a cross at 4. I am laying this out one by one, step by step, because there's a lot of things to keep track of. So taking this step-by-step approach ensures that we don't leave anything out, we keep things organized, and we make this super clear. So that's ultimately what we're doing here. We're working our way through this in a step-by-step manner. You don't have to go through it this exact way. This is my suggested method that hopefully will make it easier for all of you. Okay, so then on to step number 4. This is a 5th degree polynomial, because if I were to multiply all this out and expand it, we did this at the start, like x squared, and here's 2 more x's, so that would be x to the 4, and there's another one, so x to the 5. So I'm going to write 5th degree, and I'm doing this because I'm thinking back to my n behavior, like where it starts, where it finishes, and all of that stuff, and it's the degree that we look at in order to be able to tell that. So 5th degree, and then notice here in factored form, we have a negative lead coefficient. That's how I tell my n behavior. So that means I'm going to start up in quadrant 2 to down in quadrant 4. That's the reason why I looked at this and this. That's what helps me to figure out, and you can go back to your notes or the video from last day to help figure this out or refresh your memory. But we use the degree and the lead coefficient to help us to determine the end behavior. So that's what we're doing in step number 4. Step number 5, we have, if it's a 5th degree, we have 4 turning points. So remember, there's a couple of different ways that you could look at that. 4 turning points or 5 changes in direction. I apologize. I know that this is not the neatest printing ever. As you know, this is usually what my printing's like, but it's even worse because I'm writing on this upright. So bear with me. Hopefully the fact that I'm verbally saying it and writing it should make it at least somewhat legible, and you're able to follow along. So, step number 6, we want to test points between, okay, I'm going to actually write it out. Test points between our zeros. So between 0 and 2. Yeah, just between, we'll start with that maybe. So testing points between 0 and 2. So maybe we can just test 1. Test the value 1. So that would mean I just plug in 1 for x. So that would be y equals 1 squared, 1 minus 2 squared, and 4 minus 1. So I'm just plugging this back into the original equation, and I end up getting 3 when I plug it in. So that tells me I have the point 1, 3 on there. And I'm going to highlight this because this is a lot of things to keep track of. I'm going to highlight that as well. I'm going to highlight that as well. So all this stuff that's going to be useful to me, I'm going to highlight it. These are just strategies or tools for me to use. And then I'm also going to test a point between 2 and 4. So maybe I'm going to test 3. So y equals 3 squared and 3 minus 2 squared and 4 minus 3. And I will move this up. I know we are running out of room. I'm going to move this all around so that we can keep track of this. And I end up getting 9. So I have another point that is at the point 3, 9. And I'm going to highlight that. I am going through step by step, writing down each and every little thing to show you what is happening. You find your method of what works for you. So I believe you will get quicker at this. You won't have to write everything down, but this is to really clearly lay out all the different things that we are working with. And then we want to put this together because you probably have forgotten at this point, but what we were wanting to do with this was to graph this out. So, can I graph this out? Yeah, I'm going to go over to the side here so that I can also take note of all the things we've written here and use it to apply to this point here. Hopefully you can see this and follow along. So when we go to make sense of this stuff, I'm going to start with my y-intercept first. I know that that's at the point 0, 0. So I'm going to mark that down there. You know what, you guys? I am going to even take it a step further to color code this so you can see exactly where I'm getting stuff from. So I'm starting with my y-intercept. And then I'm also going to go through my roots here. I'll do them in green. So 0 and 0, yeah, we already had that, so I'm sort of doubling up here. 2, I'm going to mark that down there. And then 4, I'm going to mark that down there. So I've labeled or sort of gone through where my roots are. I know I have a bounce at 0, a bounce at 2, and a cross at 4. Okay, I'll come back to that stuff in a minute. Maybe what's going to help me is to also look at my test points. So 1, 3. Maybe I will do that in this lighter green here. So 1, 3 would be, I don't know, 1, 2, 3. I'm going to mark that there and say it's about there and put a check mark. And then 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is all on video and I'm not doing the best job, but you get the idea. I'm going to say 9, so 3 and 9 up there. And this doesn't have to be totally accurate, precise. Like, we are doing this to get an idea of the general shape of what this graph is going to look like. And I'm very old school in that I like for you to go through all of the important aspects of this. Technically, we could just take Desmos or take a graphing calculator and sketch this out, but what I would like, especially the first time or first couple of times that we go through this, is for you to know the basics. Once you have a good, clear handle on the basics, if you just want to punch this into technology and spit out an answer, that's fine, but I feel like you've got to know the basics so that when you do punch it in and spit out an answer, you understand very clearly where it's coming from. That's the stuff, the understanding, that's going to help you with as things get more complicated. If you have a clear understanding of what's happening, that's the part that will be beneficial. Okay, so now that I've talked about that, we've gone through this. Let's take a look at our end behavior. So by end behavior, maybe I'm going to do it in purple, up into to down in quadrant 4. So that tells me that I would be starting, I'm going to say up here somewhere, and I knew that I had a bounce at 0 because it told me that here. It's bouncing at 0, and then it's going to bounce again at 2. So I know from here it comes up to this point, and it bounces at 2. And then I know from there it goes up to this high at 9, because we found that midpoint in between, our test point at x equals 3. And then I know that it crosses at 4. So I would go through here and finish down here. And that satisfies my end behavior here as well. So I know I took a very lengthy process to go through every single little step and lay out how we got this. But that gives you an idea of how to go about this. Like I'm talking, we went through every single nitpicky little detail, which you won't necessarily have to do, and you don't have to write it out every time. But I did want to ensure that I did that with you the first time so that you understand how to do this. Okay, so my suggestion to you is that you pause your video right now to try this next one on your own. So try it completely on your own. I think you'll actually find this one easier than the last one. And I'm just going to run through the solution right now because you have the luxury of trying at your own pace at home. So I am still going to go through the step-by-step process so that you have that in your solutions, but it's up to you how much of it you follow. So we have our roots at 5 from here, -1 with a multiplicity of 2 there, and then +1 with a multiplicity of 3 there. Okay, our y-intercept, well, that's the point where x equals 0, so I don't think we need to write every single part of it down right now. We just know we're plugging in a 0 into here. So if I throw in a 0 there, a 0 there, and a 0 there, we're looking at what we would get. And what we would get when we multiply all that out is we would just get a value of 5. So 0, 5 is our y-intercept. So I'm going quicker and skipping things because I know that you know how to plug in 0 and to multiply those values out. So we're good with that. Okay, so then the roots that we talked about, we know that this means there's a cross at 5. That's that part. And then at -1, we know that there's a bounce at -1. So that's that part because of the multiplicity of 2. And we know that there's a slide at 1 because of this part with the 3 up there. Okay, so then for the next part, we know that it's a, well, 3, 4, 5, 6 when we're looking at, so I want to make clear to you where I'm getting that from. When I'm looking for the degree, I'm looking at like 3, 4, 5, and then there would be a 1 there to make it 6. So this is a 6th degree polynomial, and it has a positive lead coefficient. How do I know that? Because in front of this first bracket, there's no negative sign. So that I assume that it's a positive. That's how I know that. Because it's a 6th degree, so even degree and positive lead coefficient, it would go up in quadrant 2 to up in quadrant 1. So it's like a W or a U or like that type of shape. Okay. And then for the next one, we would have, since it's 6th degree, I'm going to say 6 changes in direction. And that is totally your choice. If you prefer the turning points, it would be 5 turning points. Take your pick of what makes sense to you. And then we want to pick some test points. So I'm just going to give you the test points. If this is where our roots are at, we basically just want to pick something in between. So I'm going to just write here, test points. That does not look like it says points. Test points, that's better. So do you see that in between -1 and 1? So I probably want to plug in 0. Well, we already had that. It was 0, 5, so that's fine. We don't need to put another one in there. It just so happens that our y-intercept fell in between them, which is perfect. It's less work for us. And I want to pick another one in between 1 and 5. So the natural choice is probably 3. So we're going to plug in 3 into here. 3 minus 5, and then times 3 plus 1 squared, times 3 minus 1 cubed. I'm going to allow, like, I know you all know how to do that. So we would just take the number 3, plug it into there, there, and there. And your calculator can spit out an answer, or you can work it out, but the answer is actually negative 256. Try it yourselves. Hit pause on the video. Make sure that you're familiar or okay with, like, I picked the 3. You would pick the 3 because it's in between 5 and 1. So we're picking test points that are in between the two roots. So maybe what's helpful is if I actually show you on the graph why I've chosen those test points. So let's go to actually graphing this out, because this is going to be a little bit tricky. So I have a point here at negative 1. I know that I need one at 1, 2, 3, 4, 5. So there we go. I'm going to go like that. My roots are at negative 1, 1, and 5. So now do you see the reason why I chose this 3 is basically just because 2, 3, it's like right in between these. 1, 2, 1, 2. So that's to give you an idea of what the test points are or why I chose this. That's the test point. And the other one at 0, 5, well, we might as well just mark that down. I'm going to put that there at 5. So there's that point. So we're good to go with that. I'll do that in colors so you know. And that's also happens to be our y-intercept in this case. Okay, so I know it starts up in 2 and goes up in 1. And I also know, well, at 3, if my value is at negative 256, there's no way that I'm going all the way down to negative 256. So I'll show you what to do with that, because these are just sketches I'm looking for. I'm not looking for precise, perfect, accurate graphs. We're interested in the pattern of behavior. That's what I'm trying to teach you with this. Not perfection and precision and accuracy. We would use technology like Desmos or graphing calculators if that's what we wanted, which will be the case in some examples, but for now it won't. So we'll just do a sketch. We're trying to get the general pattern. That's the idea behind this. Okay, so we know that there's a bounce at negative 1, and I know that I start up like this. So it's going to bounce from here and go up to here. And I know that there's a slide. So I did a bounce at negative 1. There's a slide when I get to 1. So from here, I come down to 1, and I just slide or hang out here for a bit before it comes down. And when it comes down here, I'm going to leave it quite open, because do you see that it would come down like really, really, really far off of our graph? If it's going down to negative 256, it's going to be a drastic drop down. And that drastic drop down means it's also going to come back up to 5 and cross at 5. So I'm going to come back up like this and say, ooh, except not so crooked there. You get the idea. It's going to come back up and look something like that. So it looks like we have a big gap in between here. That's because the values are shooting way down. It's okay for us to demonstrate it this way, or I get that you don't have, your page might end here. If you had just ended it here at this dotted line, that's totally fine. This gives me an idea and lets me know that you know that something weird happened here, where there was a dramatic drop down. Okay, so here is your suggested work for today. Page 127, numbers 1, 6, and 8, and we'll do the second half in the next video. Thank you.